So in this video we're going to take a look at the equation of a path. Now there are two types of equation which you can have. You have a Cartesian equation, which is our traditional y equals mx plus c1. So you've got the equation in terms of y and x. And you have a parametric equation. Now it's slightly different, this one. With the parametric equation, your x and y terms are defined separately in terms of a parameter, usually t, but it doesn't have to be t. So what we do is we take for any given value of t, we work out what the x value is and what the y value is, and we can plot the point. This allows us to work out the x and y separately. Now this is going to be we do parametric equations in year 13 as part of the normal maths course. So really this is just a quick overview of what we're doing here. A typical example of how we might do this one. So here we've got a question. If you read it carefully, you're given acceleration, and we've got to find the velocity, the position vector, and then the Cartesian equation. So we usual process, we find the velocity by integrating the acceleration, as we've done before. Remember to put our constants of integration to this. We were given starting conditions, so we were told when t equals 0 what the velocity was. So from that we're able to to work out what c1 and c2 are going to be. And therefore we can now get our expression for the velocity with the right constants in there. If we want to now find out the acceleration, obviously what we're going to do is we're going to integrate that. If we're going to find the displacement, we're going to integrate that expression. And again, with our constants in there, c3 and c4, given the starting conditions, we can establish what c3 and c4 are going to be, and this time we find them both to be 0. So therefore we're given our displacement vector. Now, if we want to find our Cartesian equation, all we've got to do is we've got to rearrange one of the terms. So you've got r is effectively x and y, the two positions of x and y. Take the easiest one, so in this case x equals 10t is the easy one. Rearrange it to get t equals, and then we substitute that into y. And then just make it look tidier. This time, as you can see, we've got slightly harder functions to deal with, in so much as we've got trig expressions. So we start off using F equals ma because we're given the force, and we can work out what the acceleration is going to be. Having got the acceleration, we can integrate it to find what the velocity is going to be. So using our usual rules of differentiating or integrating trig functions, we can establish what v is going to be. But don't forget, we're going to get constants of integration. So we have to use the starting conditions that we were given to establish what the constants are going to be. Now you need to remember that when t is nothing, the cos of nothing is 1. So 2 times 1 is 2. So that's thinking through how the values of c1 and c2 are worked out. But in this case, we're able to establish that they actually c1 and c2 will both be 0. We then need to find what the displacement is going to be. So again, we integrate the velocity this time. Usual rules, we're still integrating trig functions, so we're doing exactly what we've talked about in class before. And we find what the displacement is going to be. Again, new constants. We were given the starting conditions and t equals 0. We were told that the position vector was 3, 4. So therefore we can establish what c1 and c2 are going to, or c3 and c4 are going to be. And actually this time we find that they're going to, what the values are going to be 2 and 4. Okay, so that gives us our expression for what r is going to equal. And then we're going to find our Cartesian equation. Now we use a little bit of a trick here. So if you write them both out as before, what x equals and y equals, now you rearrange them both to get cos 2t equals and sine 2t equals. This is a nice little trick here because we know that the cos squared of a plus the sine squared of a equals 1. So if we square both sides and add them together, we know the answer is going to equal to 1. So just demonstrating that here, we end up with x minus 2 squared plus y minus 4 squared equals 1, and there is our Cartesian equation.